Okay, I'm not abandoning that previous problem. We are going to start there, but it is a great motivation for trig substitution. The problem that we were doing was secant base 5x, and the way we proceeded to do this is to split them up using secant tangent, right? Secant squared x, secant x. Caleb was the only person who tried. And Caleb failed. This is expected, nothing wrong with that. So that is the first step. And it is the trouble case that we discussed, where we have an odd power of secant, and we all know that it causes problems. I'm going to leave some space here. I'll leave that up. After that step, we split secant squared x, wrote it as 1 plus tangent squared. Why did we do that? Well, by writing it as 1 plus tangent squared, we can distribute the secant cube, split the integral. And yet again, unfortunately, we ended up with the same problem, right? Odd power of secant and tangent squared. If you observe that's an odd power, that's an odd power. Naturally, whatever problems that's happening here will happen here. And whatever happens in these two cases will happen in secant base 7x, 9x, and so on. But we did make progress, and we split it up and wrote it in a way. The first term, if I recall correctly, was ln secant x plus tangent x, right? Plus another integral, u squared times square root of u squared minus 1.
Yeah.
And then another integral is that secant cubed.
It's cross tangent squared secant.
Sorry? Next one.
Tangent squared
Oh, yeah,
secant.
that's right.
Tangent squared secant cubed. It's that integral.
Just,
Just regular
Just secant cubed.
yeah, no. Tangent squared secant.
X.
X, yeah.
Nice. Okay. And of course, secant x would simply be secant base 1. That's it. I'll do this part later. I wanted you to give that a shot using u substitution. Sorry, integration. My past did it for Caleb.
Third time, no.
At a time, no. So, odd power of secant, even power of tangent, odd power of secant, even power, odd power, odd power. All of those cases are trouble. And the way to solve this problem is to either find a way to solve this, perhaps rewrite this in that form with a radical, which I believe we encountered once before, and use trig substitution. That is our motivation. But what if I don't want to do trig substitution? Without that, the only way to do the problem is to use something called the reduction formula, which we did not cover. We know the derivative of tangent x is secant squared x dx. Agreed? So from this part, you would proceed with integration by parts, but you don't know, or I haven't gone over integrating something like that. So the color technically, gonna the color technically fail? No, it's just direct approach. But this, on the other hand, is doable. But to solve it, we need to have trig substitution. That is also doable without getting into that mess if we use trig substitution. What is trig substitution? Take a guess. I mean, we did use substitution. What did the technique involve? Me, you substitution, you, right? So U substitution had U in it. Trig substitution, take a guess.
Has trig in it.
It has trig in it, that's it. Okay. Oh, look who decided to grace us with her presence. After 3 classes. Okay. And when does it play a part when we have a root? Save this, perhaps we'll come back to this one. So if you did integration by parts, the way to do this would be to have a function and go from there. That type we did not discuss in this class. So I'm going to keep that as a motivation and go from there for trig substitution, which is 7.3. We have to use a trigonometric function and statistics. It all goes back to one guy. And who's that one guy? Huh? I disagree. Isaac Newton says Caleb. I disagree. What do you say, Tito? That's how I'm going to remember his name. Sine squared theta plus cosine squared theta equals 1. It's a squared plus b squared equals c squared. I want you to put a star here. Whatever we are going to do here is going to show up in chapter 10, section 1. So, one identity. The second identity involves secant and tangent, if you remember.
1 plus tangent squared is equal to secant squared.
Okay. The next one had
Cosecant squared plus 1.
cosecant squared theta plus 1 equals
Cosecant squared.
what?
Oh, sorry, cotangent squared.
Cosecant squared theta plus 1 equals cotangent squared. Caleb, right?
I know I said cotangent plus 1.
Okay. Did you?
Swear to God.
Okay. And I also mentioned last time whether secant tangent, cosecant, cotangent, the methods kind of go hand in hand. While we were doing this, I mentioned in case you forget these, you can easily get 2 and 3 from 1. If you divide both sides by cosine squared, you would end up getting number 2. If you divide both sides by sine squared, you would end up getting number 3. Good? It's that easy. So at the end of the day, it all goes back to one guy, and it is not Newton. But Newton did a lot of things. Okay. Why is that important? This one, do we know where it's coming from? Hard to know is this pre-calculus. Make me proud.
Hypotenuse.
Yes, but specific. We get sine theta.
So a total?
Huh? Anyone else see how you make me proud?
All the time.
Anyone else? Sine theta, cosine theta comes from, I'll give you a hint. It is in every trigonometric book. Yes, we've been over that.
Yeah.
But every trigonometry book has this in the back, or in the appendix, or in the front. Your previous professor might have said, "Oh, here you can use this too during the exam." Thank you.
Oh.
She wasn't even in pre. Unit circle. Again, with the start here, we are going to get back to this in chapter 10. Oh, badly drawn circle. Okay. Relatively okay. So, if the radius is 1, we have a unit circle. Angle theta. Any point on this circle you can obtain using cosine theta, sine theta. Agreed. So, if that is for a unit circle, if I drew another circle over here, say it was radius 4, the angle, will it change? You know, for a point that's over here, but on a circle that has a radius 4. Go ahead and draw. So, will the angle change? No, I just extended that. The radius changes, but the angle doesn't change. Every single point on the XY plane, if you took the circle out, can be represented on a unit circle or a circle with some radius. Do you agree? Yes? So, if I get rid of this circle, X and Y right here would simply translate to cosine theta, sine theta with that unit circle. X, Y right there would simply correspond to radius, or square root of radius in this case, times cosine theta and, radius times cosine theta for X, radius times sine theta for Y. Good? So, this point is 1 times cosine theta, 1 times sine theta. That point, 2 times cosine theta, 2 times sine theta. That 2 is not popping up magically. It is coming from somewhere. Where? Oh, what?
That comes from double angle, doesn't it? That comes from like the double angle.
Double angle?
Hold on, no.
Not everything is double angle the moment you see 2.
It converts, sort of.
Where is that 2 coming from?
Yes.
Very good. Radius, but the radius is not 2 negative, it's 4.
Oh, I thought the diameter was 4. I don't know.
Okay,
Okay, never mind, I was dumb.
but you are correct though. This too is coming from the radius 4.
I'm wondering.
Square root of 4 is 2.
That's what I meant.
No, yeah. That's the truth. If I make this arbitrary, I don't want to draw a bigger circle. It's going to look awful. So I'll just draw one here. But this time, I'm not going to give it, a number. I'll call it a letter A. Okay? If that is A, let's make it A squared. If that is A squared, the point on that dotted purple circle in terms of cosine theta on sine theta will be, huh? What?
A,
This one is cosine theta, sine theta.
so would it be A cos theta, A sin theta?
Very good. For the point in purple right over here, A cosine theta, A sine theta. Good. One more step and make the idea clear, I suppose. What is the equation of a circle? Again, it has something to do with Pythagoras. Equation of a circle. X squared plus okay then. X squared plus y squared equals
R squared.
r squared. What is r, Bryce?
The radius.
The radius. So instead of calling it r, I'm going to call it a. Good. Now, if you look at that expression, it is going to satisfy, that equation will hold true when I plug in a cosine theta for x, a sine theta for y. Do you agree? If I plug in a cosine theta squared, a sine theta squared equals a squared. A squared cosine squared theta plus a squared sine squared theta equals a squared. What will we get? What do we have encoded?
A squared.
A squared good. Well, it's true because you plug in 1 here, a squared equals a squared. Other way around, if you divide by a squared on both sides, you're going to go back to the first equation. Good. So if you take a coordinate on the rectangular plane, you can represent it either as a cosine theta or b sine theta. Sorry, a sine theta. Erase this. Yes. Using that logic, this is what I'm going to do. Move x squared to the other side. So y squared would be equal to a squared minus x squared. Good. I'm going to take the square root of it. Square root of a squared minus x squared. Good. Okay, so x and y in the rectangular plane is directly associated with a and theta in this system, has a name, polar coordinate system. And I derived this expression from that. Agreed? Now, if I can go from there to here, I can go from here to there. Do you agree? Relatable, correct? Math works nice. That is a function. Agreed? One would hope so. But it has a radical. If I simply threw an integral on both sides, in math, if you do something on one side, you've got to do it on the other side, so I'm integrating on both sides. With me? So I'm finding the area under that curve. Just by looking at it, would you be able to give me an answer? If so, which method would you use? Would use substitution work? We'll start there. Alex?
No, because you're never gonna be able to get A from X or X from
There is no way I'm going to get 2x outside or negative 2x outside. It's not going to happen. Is it possible to use integration by parts? Possible, but do I want to? No, definitely not. But I know this and that are related to each other, correct? And they are related to the angle theta and the radius a. What is the x coordinate up there? Cosine theta. So why not I simply put x equals a cosine theta? They are related, agreed. Why not do that? If I did that, I would end up getting square root a squared minus a cosine theta squared. What about dx? That's easy. If x is a cosine theta, what is dx? You've got to find the derivative of x with respect to theta, correct? X is a function of the angle. So dx, if you took the derivative with respect to theta, what will we get? Michael number one, do you know the answer? Negative sign. Close, almost there, okay. Negative sign, what? That's part of the answer. Negative sign theta, okay. Is that it, or are you missing something? No. What happened to that A? A is a constant, so negative A sine theta. Good. That would simply mean dx would be negative A sine theta times d theta. Good. I don't like using U. I'm not sure if the book uses U. I like to do it with theta because this is going to show up in chapter 10. Good. Okay. Almost there. I need that side, so it's going to write it over here. Going to rewrite that integral a squared minus a squared cosine squared theta times dx is negative a sine theta d theta, right? A squared, I can pull that out as a root. What will I get? Well, sure. Inside here, 1 minus cosine squared theta. What happened to that a squared? And it will become a times square root of 1 minus cosine squared theta, have an a over there. So a squared minus is going to come outside, times sine theta d theta. Good. Yes, no, maybe?
You took it doesn't say a squared sine theta, but you took
So-
it out as a.
A squared comes out as a root,
Yeah.
I have a, yes?
Oh, and then, okay, got it.
Okay. Good squeeze of thinking. 1 minus cosine squared theta is sine squared theta. What is the square root of sine squared theta? Sine theta, okay. Minus a squared integral sine theta d theta. Right? That is a trigonometric integral. Do you agree? Integrating that is a piece of cake. Do you agree? Caden knows your chance. What would you use to integrate?
That one put under pressure, I know I forgot.
Your go-to answer, Caden.
Double angle?
Yes, exactly. I could use double angle identity and get the answer. Yes. Then go back and substitute for theta, and you will finally have the solution. Does that make sense?
Why is it negative a squared on the outside? Should it just be a?
The a comes from here, but then I have a negative a there.
Oh, so you can't just like pull it out of like everything? Because if you just pull like a out of everything.
The negative a is right here, right, in the dx part.
Yeah.
And then there is an a coming from this, right? A times negative a, negative a squared. Good, okay. So what I pretty much did is use the basic trigonometric identity, make a connection between the points x, y, and if that is true, then this is true. So if I have a function that has a root, all I have to do is realize, oh, I can make a connection between x and theta, plug it in, convert it to a trigonometric integral, get the answer. Does that make sense? Not only it's going to work, provided it fits the types that we discussed. Say we end up with the secant cube type, that'll be a problem. Good? With me? Do we see the motivation on what we are doing? Yes or no? Do we have questions? before I write the types and what to do.
I just want to ask what types would you use this for?
About to show you. Good. This is just the motivation and background information. Are we clear? Okay. So don't forget this.